Hi guys, so this video is a continue of section 2.2. So in class, in section, in example 2, you can see that the 0, when x approach really close to the value 0, the y value is just opposed to 2. And that is on both sides, and that's going to be your limit, okay? The limit. And we already say that the limits only exist when the value approaching from both sides. So to find the limit of a function on the graph, we're gonna looking for on the curve. So we want to find the limit of x opposed to 3 of the function. So at x opposed to 3, as x equal 3, there are two different locations. One is the point down here, and one is the point up here. But we do, so what is the limit of x opposed to 3? Remember, for the limit exists, they must be opposed from both sides. So it's only exist for this one, right? So this is opposed from the left and the other one opposed to the right. And what y value when x opposed from to 3 from the left and right is going to be -1. So we say limit of x opposed to 3 is -1. Okay, similar to the bottom one. So this one, what is the limit of x opposed to -1 on the left and right? It's gonna be +1. Okay, because the function opposed from this to this, and that value is gonna be 1. You don't say f of -1 is not equal to 1. Okay, don't say that, because f of -1 is not equal to 1, because this is the open circle. The function is undefined at this point, okay? And remember, we say the limit is only exists when the left side and the right side approaching to the number, okay? If the left side and the right side doesn't approaching to the number, we say that limit doesn't exist. Okay, so we're gonna talk about limit existence and one-side limit. One-side limit is mean if I want to find what is the limit of x approaching to 1 on the right side of f of x. Okay, right side mean we go right like this. We go from the right like this. And the limit opposed from the right is actually where the y value is 3. So I'm gonna say this is 3. So limit opposed to 1 on the right, the positive value, the positive on the top of 1 means approaching from right. Okay, it's actually equal 3. And what is the limit of x approaching from the left, f of x? It's gonna be from here, from the left to this point. And what is the y value? Is actually 1. Okay, so look, the limit opposed from the right is 3 and the limit opposed from the left is 1. So when the limit opposed from the right of the function does not equal to the limit opposed from the left of the function, we say the limit opposed to that number does not exist. Okay, because in order for the limit to exist, the limit on the right and the limit on the left must match, but they are not matched, so that's why. And we are separating this because one-side limit, because you actually can find the limit opposed from the right, and you actually can find the limit opposed from the left, so that's why we evaluate this like this. And they compare, they are not the same, so that's why they do not exist. Okay, you can do the similar thing to example 4 as well, but it does not necessary, because if you look at the graph, they both approach to the same point already. So you don't need to separate them. All right, so let's look at this one, the big example, example number 5. All right, I have the graph. Let's combine everything. I want to find the limit of x opposed to -8. So where is -8? -8 right here, okay? And the limit opposed from the left and right of -8 is actually equal to -6 because they both oppose that, right? They both oppose to this. So it's gonna be -6, correct? Okay. And then how about limit of x opposed to 10? 10 is right here, okay? And I do have the graph from the left and the graph from the right opposed to the same value. And that value gonna be 0 for my y. So I'm gonna have this is y. Okay, you can also think of limit is actually the y value. Okay, so now this one, x opposed to -2 on the left because there's a negative on top of the 2. So we say x opposed to -2 from the left. So -2 right here from the left, right here to here. So we're gonna have from here to here. And what is the y value right there? It's 3. Okay, and when x opposed to 6, so 6 is right here, but look, I have 2 pieces of the graph, but they oppose to the different value. The limit on the 6 from the left is opposed to 2. Limit of x opposed to 6 on the left is equal to 2. And then the limit of x opposed to 6 from the right is equal what? From the right is right here, is equal to 5. Okay, and they are not the same. They are not the same. And equal. So therefore, we say this does not exist because the value is not the same on the left and right. All right, so let's look at this one. We're gonna have an unbounded limit, okay? So when x opposed to a number, there is some function or some expression that when your x opposed to the number on both sides,